Hi, I'm George Woodbury from College of the Sequoias in Visalia, California, and in this video we're going to talk about inverse functions. The basic idea of an inverse function is that it undoes the action of a function. If we have some input value x, the function f brings that to a value that we call f of x. The inverse function will reverse that pattern and bring us back to the value of x. So this is the inverse of f of x. And we have notation for that. We write that as f with what looks like an exponent of -1. That stands for f inverse of x. And again, the idea is it basically undoes what the first function does for every value of x in the domain of that function. So the definition, f and g are inverse functions if this first condition, f composed with g of x is equal to x, and the second condition, g composed with f of x is also equal to x for all x in the domain of the inner function. So if you think about it, if we were using a function g to check if it was an inverse, is g of f of x equal to x? That's a composition of functions. So we're going to, in this video, check to see whether these functions meet the definitions of inverses, and we have to check, does f composed with g of x equal x for all x, and does g composed with f of x equal x? So let's start with A. We have f of x equals 2x plus 8, and g of x equals 1/2 x minus 4. So first we want to check f composed with g of x. And I still think it's a good idea to begin with writing it this way, f of g of x. That becomes f of 1/2 x minus 4. And that tells us to substitute 1/2 x minus 4 in for x in the function f. So the function f was 2x plus 8. That's 2 times the input plus 8. We put 1/2 x minus 4 in for that input. And now we do the algebra. 2 times 1/2 x equals x. 2 times -4 equals -8. And then we have the plus 8 sitting there on the outside. X minus 8 plus 8, that equals x. So it works in that direction. We still have to verify the other direction though. So we also need to check g composed with f of x. And that is g of f of x. The function g was 1/2 times the input minus 4. So where x was, I put a set of parentheses, and in those parentheses, I put the formula for f of x. Now I distribute the 1/2. 1/2 times 2x is x again. 1/2 times 8 is positive 4, and we have a minus 4 sitting there as well, and that simplifies to x. So these two are inverses. You may be wondering, could I just try this with a value? For instance, if I plugged 5 into f, I would have 2 times 5 plus 8, that's 18. If I plug 18 into g, I should get back to 5. And 1/2 of 18 is 9 minus 4 is 5. So that's one specific example where it works, but that doesn't mean that it works for all of them. You've got to use the general input x to verify that this is true. Now, it should make sense to you that this works. In function f, we're taking an input, we're doubling it. In g of x, we're taking an input and taking half of it. In function f, we're adding 8. In function g, we're subtracting 4, but only after we've taken away half of it. So you can kind of see it happening for both of these. Now for part b, I have f of x equals 1 over x minus 6, and g of x equals 1 plus 6x all over x. So this is going to be a little more challenging with the algebra, but let's give it a shot. I'm going to begin with f of g of x, which is f of 1 plus 6x all over x. And that's going to go into x in function f. So we have 1 over 1 plus 6x over x minus 6. And we need to clean up that denominator a little bit, and we need a common denominator to do that in the denominator. And so if we multiply by x over x, both fractions in the denominator now have the same denominator, x. And we can combine those numerators, and 1 plus 6x minus 6x just equals 1. So we have 1 over x. Dividing by a fraction is the same by multiplying by its reciprocal. So that's 1 times x over 1, and that equals x. So we found that in that direction, this works. Let's verify the other direction. We're going to be working with g of f of x, which is g of 1 over x minus 6. In both places that we see x in this function, we have to replace that with 1 over x minus 6. So we have 1 plus 6 times 1 over x minus 6 all over 1 over x minus 6. We need to clean up the numerator first. In the denominator, we've got a single fraction, and we can replace that by its reciprocal, converted to multiplication. But we've got to take care of the numerator first. The second term has a denominator of x minus 6. We're going to need that. Well, that's not very clean, huh? We're going to multiply by x minus 6 over x minus 6 times 1, which is just x minus 6 over x minus 6. So we have x minus 6 over x minus 6 plus 6 over x minus 6, again, all over 1 over x minus 6. Now to clean up that numerator, they both have the same denominator, so we can add straight across. X minus 6 plus 6, that just equals x. So over x plus 6. X over x minus 6, sorry, over 1 over x minus 6. Now we can take that denominator, invert, and multiply. So I'm running out of room. I'm going to take this up to here. X over x minus 6 times x minus 6 over 1. Right, replacing that with its reciprocal. Divide out the x minus 6's. Look at what we have left, x. So we were able to get x in both directions. So these two functions are inverses as well. A little pro tip when you're working these, if one of them fails, you stop, because it only has to fail in one direction. But if it fails in one direction, it will fail in the other direction as well. And so it's a good idea to try to find the one that's going to be easier to work with. In the first example, it didn't really matter. But in the second example, I think that the left-hand side, f of g of x, was easier to work with, so I should start there because I only had to plug in one place rather than starting with the more complicated one, because if the first one fails, we're done. If the first one's successful, then we have to verify the other one as well. All right, I'll see you in the next video, where we'll talk about how to find the inverse for a given function.